Alrighty, welcome to lesson 2. Lesson 2 furthers our definition of what is a function and how to represent it. So today we're going to be using function notation to express functions that have specific inputs, and outputs. And so your input literally means going in, and your output is your result. So when I talked about yesterday about our independent and dependent variables, where our independent variable is our input value, what we're inputting in. We talked about the idea of time yesterday. And also we have our output value, which is our dependent variable, which is our output, which means what is a result. And so what we talked about yesterday was distance, or the number of times the dog barked. And so those are our outputs. If our input is our time or whatever we're talking about, our result is our output. And so define those two variables, and that's what we will be, not variables, two vocab words, and that's what we will be talking about today. And so with the first lesson, first activity, these graphs should look familiar. You actually were working on them yesterday when you either had day 1, day 2, or day 3. Here are one example of what the distance of the dog from a post as a function of time, right? Distance is our output, right? The distance from the post in feet is our output value, and we have our input value of our time in seconds, right? Each time, as the time gets inputted in, it lets me know how far we are away from our post. And so we want you to take a look at each of the 3 questions and each of the 4 questions on this slide and that slide to start to answer questions about our situation using the graph. So for example, how far was the dog away from the post 60 seconds after the dog owner left? So I want to look for, all right, time in seconds is my input value. So I know that it's 60 minutes. I'm going to go up, 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 and I notice that I touch the graph, I cross the graph, my output value is 4. I know that at 60 minutes, I will be 4 feet away from the post. And you want to do that for each one of your days. At day 2, if I'm going up to, I have 60 seconds, I know that my graph is at distance from post in feet also at 4. And so on day 2, I'm also 4 feet away from the post. And so you want to go through each question, and I know that it may seem tedious, but we want you to start building the connection between my input value of time and my output value of distance. Right now, we're talking about how far was the dog away from the post when the owner left. All right, when the owner left, I know that that is 0, right? There's no time passing since he left. And so at 0, what is happening in my functions? And so we are looking for how far away. We're looking for our output, which is our distance. And so I know that at 0 time, my dog is around 1.5 feet away from my post. And so I want you to think about each one at a time. When I'm asking how far away, I'm looking for my input. But take a look at the next slide. We're continuing to look at how far away, which is still looking at our distance. But our last question represents how many seconds have passed. So now that I'm looking at I know the distance. In fact, over here, I'm talking about my farthest point. So I know my output. My question is, what is my input? So if the furthest away I get to is 5 feet, I can see that up here, 5 feet, and I can see that's around 50 seconds. 50 seconds, I'm at the farthest point. And so you want to think about what is this question asking me? Is it asking me my input of time, or is it asking me my output of distance? And continue to go through that as you are thinking through slide 4 as well. And so now I want to introduce you what function notation looks like. And so function notation is one way of representing our function. And so it's f of x. It's represented by f of x. And so f here, f represents my function, right? This is my function. It can be in time, it can be in distance. In this case, it is a function f that represents day 1. This is the function of distance and time of day 1. G of x, it represents day 2, and h of x represents day 3. And so we represent this as this is my input value. My x is my input value. In this case, we have t, so I'll match it up to make sure that we are consistent with our problem here. You can have any type of variable as you're going forward. This is our input value. In this case, it is a representation of time, and the entire f of t as a whole unit represents my output. In this case, my output here is a function of distance. And so if I asked you f of 15, 15 here represents my t. So I know that the distance represents 15 seconds because t is my input value. After the owner left, and since I know that there is an f here, I know that this is on day 1. And so do the same for g of 48 and h of t, right? T represents my distance, t represents my time, and the whole unit as a whole, f of t, is that we call it f of t, that's how we say it, is our output. And so think about it the same way when we have our whole situation. This entire thing here represents my distance. And so h here represents 3, right? On the third day, or day 3. We know that my number of seconds is my input value, which is 40. 40 seconds after the owner left. The dog was how much, right? The whole thing equals 4.6. And so I know my output value is 4.6 feet away. And so try to do that for every single situation. And think about how that would look in the table. This entire thing here represents distance. It represents my output. And if that output equals a value, then we can represent it that way as well. And so we'll get some more practice working with input and output functions as well. And so in the last activity, we want you to do a little bit more practice working on what represents a function and not. So I'm actually going to leave this for you to complete because we actually talked about this in our previous lesson. But think about what is our input value here and what is my output. What is my input value here and what is my output? And you can choose any birthday and day that works for you, right? Input value could be my name. My output value is the birthday is the output. My birthday is May 19th. And so complete it with 2 more and do the same on this side. And think about how many outputs are possible. If I have birthdays and inputs, how many outputs are possible and whether that represents a function or not. Think about what we talked about yesterday with what represents a function or not. And as we move forward, we'll continue to practice function notation and how to represent functions for our real world situations. If you need to look at this as well, this image is also very helpful. So I will see you in lesson 3.